Excellent. So assuming that you're all with me, you guys are doing excellent this week, by the way. So let's read in this time additional information on the global emissions. So that global carbon project data that I just mentioned, that the additional information we need in order to allocate the budget to different countries. Sang-Yeon has kindly prepared it for us on our shared Google Drive. So if you go to our shared drive and go to data, then you'll see a file called globalbudget.csv. And if you copy and paste this data set to whatever drive that you're working with, so for example, for me, it's Google Colab Notebooks, just copy and paste that file to your Colab location. So I have that right here, copy of global budget. And while you're at it, also copy this global emissions hist file to the notebook folder that you're working in. Do you have that file with you? Could you give me your thumbs up if you have that file ready in your drive?
I'm sorry, but where is the global budget .csv?
So if you go to do you remember our shared Google folder?
Yes.
Yeah, I'm just giving you the link to it. And if you go to that data folder, you'll see both of these.
Okay, thank you.
Great, then I'll move on. And if anybody's stuck in any point, do let me know. So now we're going to read in that file like we did last time. So here we're going to do the same and copy and paste that for that file name, that path name here, like this. So this may look different for you depending on where you have that Colab saved, or from which location you're working from. And I have saved that file information to a object called carbon budget path. And that's an object of that's a string object that has information about the file path that I want to give to pandas. And then here I call pandas method called read CSV because it's a CSV file. And I'm going to give it exactly the object name that I have saved the file path to in order to get the budget DF. So I have assigned that data frame to budget DF object. And to give you a brief overview of what that data frame looks like, I am using a method called head. And using a method called head, it takes in a parameter for the number of rows I want to see. So I gave it 5, and it gave me a 5 first rows of that data frame. And in this data frame, so this is a data set that Sang-Yeon has put together to help us, work with it a bit more easily. So here are temp column. The temp column gives us information about which scenario we're dealing with. So in the scenario where the global temperature is increasing by 1.3 degrees, 1.4 degrees, 1.5 degrees, and so on. So these are scenarios. These are scenarios of global temperature change. And the probability section, the probability data column gives us the probability of which it would happen. And then the likelihood. And then for each temperature and each probability, it gives us the carbon budget that remains with us. And let's just have a look at like the full data set to see what other values we have. So as you can see, there are temperatures, so there are like 2 degrees as well, and all the probabilities. So they're like, high, if the likelihood is higher, you'll have higher budget depending on the temperature. And as you can see, for like the lowest temperature rise with high probability, we have very small budget left. And the list goes on. Do you have the data set with you? Any errors you're encountering? Can I please get a thumbs up if you have this read into your data frame? Excellent. 3 thumbs ups. 5, 6. Yes. Just one more. 6. Yes. Great. Excellent. Thank you. So now let's make a subset of this data frame in order to work with 1.5 degree scenario. So for us activists, we are interested in keeping the global temperature rise to 1.5 degree. So we're going to take a subset of the data set that is 1.5 degree. And how we do that? So it might seem a little complicated, but you take the data frame name. Yes, Emmy. How does each, oh yeah, so this is for global. So there's no country name assigned to it. And our goal is to allocate this global budget to individual countries that we have here based on the fair responsibility principle, based on GDP, based on CO2, based on population. Does that make sense? Excellent question, though. Where were we? Yeah. So now we're going to use the bracket again. And if you use the bracket, it'll give you a list of like what you can call from it, but ignore all that. And we're going to write the data frame name again. And in order to give it, like in this bracket, we're going to give it a condition. And what does a condition mean? And let me just demonstrate for you. So budget, DF, and let's say, so this is how you call a column of a data frame, right? So if you run this, the budget, so if you select temperature column only, then it'll give you like one series, as you can see here, right? And let's give it a equal sign, double equal sign. And double equal sign means it's going to test whether something is equal to what. So let's say 1.5. And if we run that, then for each row, the pandas data frame is going to test whether the value of each row is equal to 1.5 degrees or not. And as you can see, there are many falses and there are true ones. And if we use this condition, so this is a condition, if we use this condition inside a bracket next to the data frame name, then it's going to create a subset of that data frame that meets that condition. So if we as I said, if we put this under a bracket for the budget data frame, then what we're going to get is a subset of that long data set where temperature is 1.5 degree scenario. And then we're going to, so this is a view of a data set. And in order to make it an actual data frame, we need to copy it. And here I'm saving that result to another data frame called budget 15DF. And if you have a look, this is what our data frame would finally look like. Are you here with me? Any question about the condition? Excellent. Excellent. Great. This is a gem. You will do this over and over and again when you're doing data analysis. I do this literally every day 1,000 times. So this comes in very handy. So you better get familiar with it. And there are other ways of subsetting data. There's ilog, there's log. This is like locational kind of subsetting. And there's also query. Query is something that you can use to like, you can use SQL command, like SQL language to do this. Like, for example, you can do it like this, and then you'll get the same result. So there are many ways of doing it, and you can Google different ways of subsetting data set, or even ask ChatGPT, and you can like learn about many different ways of doing it. But here we're going to take the most common approach. So in this data frame, if you have a look, the budget here, it's given in unit GCT. So this is gigaton of carbon. And what we're interested in is carbon emission, like CO2 emissions, right? So we need to convert the unit of this data here. So this data, we're going to use this conversion rate. 1 gigaton of CO2 equals 3.667 gigaton carbon. And so we are going to create another column that has a converted unit data. So let's go back to this. So let's just do this, right? So right now in this data frame, it doesn't have budget CO2 column, as you can see here. And we're going to create that column by giving it the column name we want it to be, and then write out the operation that we want it to do. So budget, so we're going to take this budget column here and then multiply that by 3.667. And then what you get is a new column. Then what you get is a new column that has the converted unit. So this is the original data set, and that's the new data set after this operation. This is also another gem. I do this all the time, 1,000 times every day. So this is how you create a new column using operations based on currently existing columns. You can also do something like this, your name, like this is your analysis. So let's give it your name to a new column. And if you do that, then it'll have a column with your name on it. And as you can see, in this operation, this did the operation for every single row, right? And this one, you just gave it one single string. And what that's going to do is copying, like giving that value, the same value for each and every row. So let's actually give it like a useful information. So unit conversion. Let's do this. And then we're going to have like where we can see in our data frame what unit conversion was applied to convert this budget information to budget CO2. Any questions on that? Thumbs up if you have it right. Are you here with me? 2 thumbs up, 3 thumbs up, 4, 5. One more, guys. One more, guys. Great. Thank you. Amazing. So now what we need to do is we're going to subtract emissions from 2020 to 2023. The reason why we do this is because the data that Sang-Hyun has prepared for us, it doesn't account for the emissions that has already emitted in 2020 to 2022, because the data was produced before that. So we need to, but now it's 2025 already. So we need, but we're working with CO2 data for 2023, right? So we're gonna call additional information on global historical emissions data, which is already very nicely prepared for us. And then we're going to subtract that from the carbon budget information. So the historical emissions file that I've asked you to copy, let's read it in the same way we did for the other ones. So just gonna run this. So the historical data looks like this. We have series name, we have series code, country name, country code. Country name and country code is world, because we're working with global budget, so we only take the global historical emissions. And let's see, the interested columns, the columns that we're interested in is actually just these 3, right? That's one thing to note. The other thing to note is the data, the actual data that we're interested in is only in the first row. So what we can do is giving read CSV another parameter, and that parameter would be n rows. And this tells you how many rows you need to read the data for. And now we have a very clean data set, not very clean, but it'll be cleaned. And I wanted to show you this function. So you can get the list of columns by accessing, so just call the data frame's name and then call columns without brackets, then you can just print out the list of columns that exist here. So this comes in very handy. And by using a function called len, you can get the number of columns. What len does is it counts the number of elements that exist in this list. So we have 8 as a result. So we have 8 columns. And so let's clean the data set. As I mentioned, we only need data for 2020 to 2023, right? Oh, actually, yeah, 2023, right? So we're gonna do the same as this. So we are creating, we're only selecting the data set, the columns that we're interested in, and then we're creating a copy of it. And we also, I mean, we don't need to do this here because we just clean the data set above. And the next operation we're going to do is, remember how we got the list of column names by doing this? And if you take that object and write out a string of column names that you want to save it to, then you can actually change the name of column names like this. So we went from this to this after these operations. And it's important that you give the column name, the number of column names that you give needs to match the number of column names, as well. So for example, if I was doing this, 1, 2. So there are 4 columns, but I gave it only 2 column names, then it won't work because it doesn't match. The length doesn't match. So now we have clean data set. Do we all have a clean data set? Can you give me a thumbs up if you have a clean data set? Help me out. Great. 2, 3. Is there anyone who doesn't have a clean data set? Put a thumbs up if you're not here. Put a thumbs up if you are here. Thank you. I assume that you all have a clean data set. I trust you. And I'll move on. Great. And then what we're going to do is take the sum of all these values. And how we might do that, there are many ways of doing it, but the simplest way of doing this is just take the whole data set, because we only have values that we're interested in. There's nothing else, no clutter. And we're going to call the sum function method. And then we're going to give it the parameter value for axis equal 1. And axis equal 1 means it's summing across columns. So it's summing values like this, rather than summing values here. If you gave it axis 1, axis 0, then it'll try to sum like some one row, and it won't work because it's a data frame, not a series. And if you take that, then what you're going to get is this so this value. That's the sum of all the values from 2020 to 2023. And this data set provides data in megaton of CO2, not gigaton of CO2. So we're going to convert it to gigaton of CO2, which uses 1,000. So it's like we have to divide it by 1,000. So we're going to divide that value by 1,000, which gives us 151. And then finally, since we have the historical data on CO2, let's subtract that from the current budget we have. And so if we run it, so what we're going to do is we're going to save that operation to a new column. And that new column already exists. We're just overriding the budget that we calculated. So be very careful with, like saving new operation to existing column, because you'll lose the data that you will have if that's wrong. So, but in this case, we're just going to override it. No worries. And then you're going to take the original column and then subtract this historical emission value that we calculated in order to get the remaining budget. And what does the result look like? What does the result look like? It looks like this. And so this is the budget now we're working with that considers historical emissions And now we're ready to finally allocate it using GDP and all other columns that we have put together in our clean data set. This is what we have prepared for this week. And next week, we're going to have a final data set of the carbon budget allocated to national level. Are we all good? Is there any question from the floor? Was anything unclear?